Assalamualaikum and hi everyone. In this video, we're going to discuss about classifying and summarizing the data. Alright, so let's first go to the data classification. I hope you all still remember that this is the fourth step of the statistical problem solving methodology. Okay, after you have done all your data collection, you have collected all your data. Okay, then comes the step of classify and summarize the data. So perhaps when you have done the data collection, this is how your raw data is going to look like. All right, so you can see here, this is an example of raw data. You will get a lot of data values. Okay, for variable mpg, you have value 16.9, 15.5 and so on. For variable car, you have data value Toyota, you have data value Audi, Mercury Grand Marquis. Okay, I don't know how to pronounce that. Okay, but yeah, for each variable, for each data, you will get a lot of entries. Okay, a lot of data values. So in this example, let's count how many data has been collected, how many variables were in this example. So 1, 2, 3, 4, 5, 6, 7. Okay, there are 7 variables, 7 data in this data collection. So once you have collected your data, the next thing you need to do is to classify them. Okay, to classify them, we need to see whether is it a quantitative data or is it a qualitative data. Okay, so what is a quantitative data? Basically, it's just numerical data. Okay, the variable that has numerical values. Itulah quantitative data. On the other hand, qualitative data is the variables which has non-numerical data values. Let's take a look at the example again. So in this example, you can clearly see that variable car has non-numerical data values. So car is a qualitative variable, right? Variable cylinders. Okay, variable cylinders has numerical data values. Therefore, variable cylinder is a quantitative data. Alright, so let's take a few more examples. Okay, gender perhaps. Okay, what about gender? Gender has 2 values, male and female. Obviously, this is qualitative data. Alright, weight, maybe 54 kilograms, 71 kilograms, 67 kilograms, a lot of possible values for weight. And then, so this will go to quantitative data. Excellent, alright. Next, maybe let's take a look at Likert scale. So this is Likert scale, right? Maybe you were given like a survey form asking you about your preference or your satisfaction about a certain service. Okay, so you can choose, is it very unsatisfied, neutral, satisfied or very satisfied. So this is again, betul, correct. This is non-numerical, so this will go to qualitative data. Right? It's pretty easy, right? It's not that hard to classify them into quantitative and qualitative data. Moving on, let's look at the exam grades. So we have A minus, B plus, B and so on. So yes, this is non-numerical, it's quantitative data. And finally, another example is frequency of exercise. How many times you exercise in a week or in a day? So the answer, the possible values is will be numerical. So this is your quantitative data. Okay, so that is how you classify quantitative and qualitative data. Right, so that's how you do the classification. It's pretty easy, right? Now, but it doesn't end there. Okay, there is another level of classification you need to do. Okay, so this is just the first stage, quantitative and qualitative. So now let's focus on the qualitative data. All right, under the category of qualitative data, there are still another 2 categories, which is called nominal data and ordinal data. Nominal data are the variables that cannot be ranked, qualitative variable that cannot be ranked, and ordinal data is the qualitative variable that can be ranked. For example, gender, male and female, right? So male and female, you cannot rank male and female, which one is higher than which one comes first, which one comes next. There is no ranking for gender. The values cannot be ranked. So therefore, gender is nominal data, qualitative nominal data. Get it? Okay, next, the Likert scale. Can you put a proper ranking to the Likert scale? Yes, of course, the very unsatisfied should be the bottom, and then followed, and then moving up, you will have unsatisfied, neutral in the middle, satisfied, and at the top should be very satisfied. So therefore, Likert scale has data values that can be ranked. It is considered as the ordinal data. And finally, exam grades. What do you think about exam grades? Can you rank the exam grades? Yes, you can. So exam grades is considered as qualitative ordinal data. Alright, okay, so that's another classification under the category of qualitative data. Next, let's take a look at the two classification under quantitative data, which are discrete data and continuous data. So discrete data are the variables that you need to count in order to get the data value. You need to do counting, 1, 2, 3. That's considered as discrete data. And continuous data is the variable which you need to do measurement to get the data value. For example, frequency of exercise. Do you measure or do you count how many times you exercise? You count, right? So this is discrete data. So you see, discrete data has whole number values. The data value should be a whole number. Alright, so frequency of exercise is quantitative, discrete data. Next, weight, 54 kilograms, 71 kilogram. How do you get this value for the kilogram? You need to use a weighing scale, correct or not? You have to step on the weighing scale and measure your weight. So measurement is involved. So this is considered as the continuous data. Weight is a quantitative continuous data. And yes, for continuous data, you may have decimal point number value. But for discrete data, it will only be whole number. Continuous data, it can be whole number, it can be in decimal places. Macam tu, okay? So after you do this classification, okay, you identify, is it qualitative nominal or qualitative ordinal? And then, is it quantitative discrete or is it quantitative continuous? Okay, after that, there's another stage of classification which you need to find out the levels of measurement. Okay, you can see this is a chart that will show you how the classification goes. Okay, so another level is to classify them according to the levels of measurement. So there are 4 levels of measurement in data. For data, nominal level, ordinal level, interval level, and ratio level. Nominal and ordinal level, these two are for qualitative data. Interval and ratio level, these two are for quantitative data. So let's take a look for the qualitative data first. So originally, the nominal data, qualitative nominal data is nominal level. As simple as that. Okay, straightforward. Qualitative ordinal data is ordinal level. So it's actually the same thing. It's pretty easy. The level of measurement for qualitative data is also its type. Alright, so it's very simple. But it's a bit different for quantitative data. Okay, quantitative discrete data may be an interval level or ratio level. Quantitative continuous data may be interval level or ratio level. So what differentiates between interval and ratio level? Interval level has no meaningful zero, yes, and then ratio level has meaningful zero. So what is this meaningful zero, you may ask? Okay, meaningful zero is like this. Let's talk about this variable, frequency of exercise. Okay, let's say, okay, let's consider the data value 3. What does value 3 tells you? So it tells you that, okay, this person exercise 3 times in a week, right? Okay, what about data value 2? So this person exercise twice in a week. What about data value 0? So this means that the person did not exercise at all. So the frequency of exercise is 0. This person doesn't exercise at all in a week. So the 0 brings meaning to the variable. It really means that no exercise. So it is a meaningful 0. So frequency is a quantitative discrete data with ratio level. Let's try another one. What about weight? Okay, does it has meaningful 0 or is it no meaningful 0? Okay, so let's think about the value. 54 kilograms. So this means that this person weighs 54 kilograms. So it's meaningful. So, or maybe let's not talk about people. Maybe it's a weight of a bag of flour. Okay, so if the bag is 10 kilogram, it means the flour, there are 10 kilogram flour in that bag. Okay, the weight of flour in a bag. Okay, that is the variable here. Okay, let's imagine the variable is weight of flour in a bag. Flour, tepung, F-L-O-U-R. Okay, so what if you do the measurement and you get 0 kilogram? What does it mean? What does 0 kilogram means here? It means there is no flour in that bag, right? 0 kilogram. So again, this is a meaningful 0. So weight is quantitative data, quantitative continuous data at ratio level. Okay, so actually there are not many quantitative data which are interval level. It's very hard to find. Okay, kalau ada pun, for example, IQ test. Now, why is IQ test considered as interval level? Because it has no meaningful 0. Now, if you do an IQ test and you get an IQ of 100 something, so you will be considered as maybe a genius or intermediate, correct? But what if the IQ test result turns out to be 0? Now remember, IQ test score is to measure a person's intellectual ability, right? So if it turns out to be 0, if the score is 0, does it mean that person has no intellectual ability? That is impossible, because everyone has their own level of intellect. Maybe that person gets 0 in the IQ test score because the test is not suitable for that person. Maybe it is for someone older. You give a younger kid an older person IQ test, so that's why that kid couldn't score at all. Alright, so in this case, 0 in IQ test does not mean a person has no intellectual ability, because everyone has intellectual ability. Okay, so that's why this is not meaningful 0. IQ test is considered as interval level. So another example is temperature and shoe size. Okay, class? So that's it. That's how you classify your data. You need to make sure to know whether is it quantitative discrete, is it interval, or is it ratio. For qualitative data, is it nominal or is it ordinal? Alright, itu dia. Okay, classification of data. Please try on these exercises on your own. Okay? And that is the fourth step to classify the data. Next, let's look at data summarization. So the things that you can do in data summarization, the things that you are going to do in data summarization is basically you are trying to summarize all your data. Remember the raw data that I showed you earlier? Okay, you're going to summarize all the list of data after you already classify them according to categories, and then now you want to summarize them. Okay, so imagine a quantitative data. So there are a lot of entries there. So you're going to calculate all these values and come up with mean, standard deviation, variance, median, mode, all that. So this mean, median, mode is to summarize the list of data that you have. Okay, so data summarization using those mean, median, mode, and so on. And another way to summarize your data is by using graphical summary. So I'm sure you are familiar with all these graphs, okay? Histogram, frequency polygon, OGIF, bar chart, Pareto chart, pie chart, and time series graph. So these are some descriptions on the different types of charts for you to just refresh your memory, recall your knowledge, okay? You can read on this. And this is the different shapes of histogram that you may get if you use histogram to plot your data. For example, okay, maybe you want to plot the data about students' CGPA. So if you get something that looks like this, if your histogram turn out to look like this, it means that the student's CGPA has a bell-shaped distribution. So if you were to tell someone, Miss Zahira, I have done my research, the student's GPA turned out to have a bell-shaped distribution. So Miss Zahira will understand, oh okay, which means most of them are in the middle. Okay, a lot of them get average CGPA, some of them score very well. Okay, those who are on the right hand side here are those that score very well, and then there are some of them who didn't score that well, but then the one who overperform and underperform are imbalanced. So that's what I can understand when you tell me it has a bell-shaped distribution. Okay, so the shapes of distribution can help you to describe about your data. Okay, all right. So let me introduce to you some other forms of shapes. Uniform shape, J-shaped distribution, reverse J-shaped distribution. You can see in J-shape the trend is like increasing, continuously increasing towards the right hand side, and for reverse J-shaped, the trend is like decreasing towards the right hand side. And then this is right skewed distribution. You can see some, like it's not, it increases and then continue to decrease macam tu, okay? So most of them are on the right hand side and fewer on the left hand side. So this is left skewed distribution. Bimodal, when you have two distinctive peaks, okay? And this is U-shaped distribution, alright? So if the student CGPA has a U-shaped distribution, then I will be very worried. As a lecturer, I would worry because it's like extreme. So many people who underperform and also so many that is overperform. So this is like an extreme trend, okay? Right, so these are the different shapes of histogram, and then you can still read on this. Please read on this to just recall your memory about what is bar chart, Pareto chart, and pie chart. Okay, time series graph, stem and leaf plot, and also box plot, but the description is not included in this slide. It's okay. Right. So you have so many types of graphical representation that you can use. So which one is appropriate for which type of data? So let's talk about that on this slide. Okay, so if you have a quantitative ratio scale data, ratio level, so it's better for you to use histogram, bar chart, or stem and leaf plot, and also box plot. If your data has a symmetrical distribution, it is best to represent the shape of the distribution using histogram or bar chart. But if it is a skewed distribution, then the best representative will be histogram, stem, leaf plot, or box plot. So all three will be a very good representation of the shape. Okay, if you have a categorical data, non-numerical, qualitative data, okay, it doesn't matter, qualitative nominal or qualitative ordinal, you cannot use histogram. You can use histogram, but it will not be the best representation. It is best to use pie chart or bar chart. Okay, so this is classification and summarization of data, which is step 4 in your statistical analysis. And then after you're done with the classification and summarization of data, then you are ready to present your graph and analyze your graph, analyze your mean, median, and mode, okay, using various tools in applied statistics. Okay, so you will learn this in chapter 2 onwards. Okay, confidence interval, hypothesis testing, ANOVA, goodness of fit test, contingency table, regression, and correlation. Right? So all the summarization, mean, median, all the graph will be analyzed, will be presented in this step number 5. Okay, you will learn more on this from chapter 2 onwards. And finally, you make a good decision or a good conclusion about the data that you have analyzed. Okay, the correctness of this decision or conclusion depends on your analytical skill and the quality of the data that you collect. Quality of the data, meaning that you really collect the data from the defined subject. Okay, you do not collect the data from someone which is not within the range of your population. So yeah, all that will contribute to the quality of your decision and conclusion. Okay guys, thank you so much for listening in. Now watch my next video to learn more on how to summarize your data using mean, median, mode, and mid-range. You have learned that, I know, but there is more to it to learn. Okay, so I'll see you in my next video. Bye.